Hey guys, today we're going to be doing a lesson online. So you're going to be listening to the video and following along. You should have picked up 3 papers when you came in. The first one is this one, looking at areas of squares. The second one talks about investigating Pythagorean theorem. And then the third one is the one with all of the triangles. So if you don't have those 3 papers, please make sure you pause the video and get up and get it for me. And also throughout the video, you need to be making sure you follow along because it will be asking you questions based on the video and what we're examining. So what we're going to do today is we're going to be looking at a right triangle. And our goal for today is to look at the relationship between the lengths of the legs and the hypotenuse of a right triangle. Now I know a lot of those words are new to you, so I'm going to explain what we mean by the legs of the triangle and the hypotenuse before we begin investigating. So first off, right here where it says A, this is going to be a length of our triangle, and B is also considered a length of a triangle. Now, how do I know that that's my length of my triangle? Well, if you look right here, we have what's called a right angle or a 90-degree angle. The lengths of a right triangle are always, or the leg of the right triangle are always connected to the right angle. Okay? Now the next word that I said was hypotenuse. So we're going to look at the hypotenuse right here across, right here. That's a cool word, hypotenuse. So I'm going to spell it really big for you. It's hypotenuse. Now the hypotenuse is the length of the triangle that is always across from the 90-degree angle. Okay, so we have our legs and we have our hypotenuse. So the legs are attached to the vertice of the 90-degree angle and the hypotenuse is always across from the 90-degree angle. Okay, so what we're going to do today is we're going to explore the Pythagorean theorem. So the Pythagorean theorem was first looked at or discovered by a man in ancient Greece called Pythagoras, and that's where they get the name Pythagorean theorem. And he investigated a theorem for all right triangles. So our goal for today is to explore this theorem and describe the relationships between these 2 legs and the hypotenuse of the right triangle. So the first thing we're going to look at is we're going to look at this sheet right here. And we're going to investigate the areas of the squares of right triangles. So go ahead and get this paper. And our goal is to figure out the pattern of the areas of the squares. So if you do see, we do have our triangle within the squares, but I want to focus mainly on the area of the boxes connected to the triangle. So here's one leg, right? Here's the other leg, and then across from that is my hypotenuse. So let's go ahead and look at the areas. So if you look here on the grid, anytime you have a box that connects, this is 1 unit square. Okay, so we're going to find the area of all of these boxes. So if you look at A, right here I have 1 square. So the area of this would be 1. Then I have another square, and the area of this square would be 1. Now if we look at the last square on that triangle, it doesn't look right on the dots. So if you look here, what I'm going to do is I'm going to break this up into different triangles like this. Okay? So if you look here, if I add this triangle to this triangle, that would be 1. And if I add this triangle to this triangle, that would be 1. So this would actually make an area of 2. Okay? So all I did was combine two of the triangles to make one box, and then combine two more triangles to make another box. Now, some of the boxes are going to be a little tricky to find the area, so stay with me and then you'll understand what I'm doing. So the next one we're going to look at is B. Now, if I look at B, I'm going to look at the legs first with the area. So this one right here has one box, so the area is 1. This leg right here, actually, we can cut it in half here. And we have how many boxes? 1, 2, 3, 4. So this area is 4 units square. Now the next one's a little tricky, so watch carefully. So I have a box in the middle, so I know that's 1. But if you notice, the next part's a little tricky. So what you have to do is kind of look at it this way. I'm going to look at it like a square. So I just connected it and made it a square. A rectangle. Now if you look at the length of this rectangle, I'm going to have 1, 2 at the top. And then vertically I have a 1. So what's the area of a rectangle that's 2 by 1? Well, that would be 2. But I don't need the whole rectangle. I only need half of it. So if the area is 2, then I know that this part would be what? It would be 1. This would be 1. Then if you look here, it starts to make the same thing all the way around. So if this is 1, what does this have to be? 1. This also has to be 1, and this has to be 1. So if we count all of them together, we get 1, 2, 3, 4, 5. So I'm going to put a 5 right there. So I'm going to pause just for a second to make sure you guys get caught up. All right. So I'm going to do one more with you, and then I'm going to have you explore the other one yourself. So let's look at C. So C, if we look at the legs first, I have 4 boxes here. So 1, 1, 1, and 1. So that's 4 units square. And then if I look here, I have a 3 by 3. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 here. Now the next one's going to be a little trickier, so let's see what we got here. Well, I see a box right here. So that's 1. Then I'm going to make my box a little bigger this time, I think. If I go this direction, and go this direction. So if you see right here, I'm going to make it a little bigger. So this one would be a 1, 2. That's a 2 by a 1, 2, 3. So 2 times 3, that would give me an area right here in this box of 6. So what's half of 6? So if I do 2 times 3, that equals 6. And then, but I only need half of the box, right? So then that would be divided by 2, and that would give me an area of 3. The area of this would be 3. So then I'm just going to complete this one. That would also be 3. Complete this one. That would be 3. And then this one would also be 3. So if I look at this area, I have 3, 6, 9, 12, plus 1, which gives me an area of 13. Okay? So go ahead and pause the video and see if you can do D, E, F, and G. And as I go through it, I'm going to stop and ask you questions throughout. So I'm going to pause right now and go ahead and look at D. Let's see if you get the right answers. Okay, hopefully you got the right answer. So let's go ahead and look at what we got. So let's go ahead and look at this bottom square. And I want you to tell me, what is the area of this square? Okay, you should have gotten 1. Now I want you to look at this next box, or square. And we have an area of what? What did you get for this one? So you should have got 1, 2, 3, 4, 5, 6, 7, 8, 9 for this one. Good. And the last one, let's see who got the last one. So what I'm going to do is I'm going to look for my middle part. So I went from here to here to here to here. And I got 1, 1, 1, 1. Okay. Now we got to make us another box to figure out this outside. And we're going to use, it's going to have to go outside. So here's a rectangle that I'm going to use right here. So if you look here, I'm going to connect all of this together. Okay. So this is a 1 by 1, 2, 3. So I'm going to do 1 times 3 equals 3. And then half of 3 would be what? So you should have got 1.5. So I'm going to put 1.5 here. And then that means I know that all of these now are 1.5. So you should be filling all this in. Okay, now let's count the whole area together. We have 1.5 and 1.5 is 3. 1.5 and 1.5 is 3. So that's 6, 7, 8, 9, 10. You should have got an area of 10. Okay. So what I'm going to do is I'm going to go back right now and I'm going to circle all my areas so that I know what we're working with. So the first one I had 1, 1, 2. Then I had 1, 4, and 5. And then I had 9, 4, and 13. And then I had 1, 9, and 10. So that's what we got so far for our areas attached to the length of the right triangle. All right, pause the video and go ahead and try E. All right, so you should be done with E by now. So let's look at this one first. This one should have been easy for you. This is the leg right here. So we want to find the area. So we should have gotten 9 for this one. Then the other leg should have been easy. So what did you get for this one? It's a 4 by 4, so you should have gotten 16. So we got this one. We got this one. Now we got to figure out the big one. So let's look at it carefully. So I'm going to say, I'm going to look at it like, something I like to make my big, we can do it this way, we can that's going to put it on there. So what I'm going to do is I'm going to make a little square in the middle, right here. Okay, I know these get to be a little challenging. So I'm going to look at it like this way. Does everybody see that? So I should be able to do that all the way through. Oh, you know what? I should have come all the way down with this one. Go ahead and make that one all the way down, guys. then we're going to put our, so this is a 3 by 4, right? 1, 2, 3, and then 1, 2, 3, 4. So 3 times 4 is 12, and what's half of 12? So that would be 6. So half of it, right here, would be 6. So we're going to circle that. So if that's 6, then I know that this would be 6, and then this would be 6, and then this would always be 6. Okay? So once you find out that corner one, then you can find out the other one. So we have 6 times 4, which is 24, plus the 1 in the middle. So that would give us 25 total. Okay? All right. Now do F and G, and I'm going to come back and show you the answers for that. All right. So what did you get for F? What did you get for this box? So you should have got 4 for that square. Now what did you get for this box or this square? You should have got 4. And the last one, if you were confused, you should have looked at it like this. There's a few ways you could look at it. You could look at it this way. So I saw 4 in the middle, right? Now let's draw our box. We got to find a box here. I don't know why I keep calling it a box, a rectangle, right? And this rectangle is 1 by 1, 2. So what's half of that? That would give us 1. So we should have a 1 there, a 1 here, a 1 here, and a 1 here, a 1 here, a 1 here, 1 here, 1 here. So our total area should be 8. All right, now the last one you have to do all on your own. And I'll be back in a second, and you're going to have to put in all of yours. Okay, so these should have been easy for you guys. You should have got 9 and 9. And then the last one you should have got 18. Now, how did I get 18? Well, you know, there's so many ways to look at it, but you could have also looked at it this way. So this one is a 1, 2, 3. This one is a 1, 2, 3. So 3 by 3 is 9. What's half of 9? 4.5. So you would have 4.5, 4.5, 4.5, 4.5, and that would have added up to 18. Okay? So now we have all of our areas of our squares. So if we're looking at this, it wants us to see if we can find the area of the squares that are made on each side of the triangle and find a pattern with the areas of the right triangle squares. So can you find a pattern between the areas of the squares? So I'm going to pause it and let you investigate the 3 areas of each triangle of the squares and see if you can find a pattern. Now, I know I asked you what the pattern is, so let's talk about it. When I look at A, right here, I saw that I had a 1, and a 2 for my area. And I said that if you take 1 plus 1, that would equal 2. Then I said, well, that's interesting. I wonder if B would do the same thing. So this is A. So if I look at B, I found that the area of the legs were 1 and 4, and the hypotenuse's area across the box, sorry, the square attached to the hypotenuse was 5, and I saw another pattern. I said, well, 1 plus 4 is 5. So let's see if it'll work for all of them. What about C? Well, C, we have 4 plus 9. Does that equal 13? Yes. So all of these are checking out. So go ahead and do you find the same pattern for the rest of them? Go. Now we just explored the Pythagorean theorem, and it wants us to write the pattern in a formula. So the Pythagorean theorem states this, that the area of the two squares here would equal the area of the third square. So what does that mean? If we take the A and we square it, and we take the B and we square it, that would equal our C squared. So what do we mean by A, B, and C? Well, remember in the beginning we talked about that on a triangle, the legs are considered our A and our B, and the hypotenuse is considered our C. So if we take A, the length of A, and we square it, like we did here, the length of A was 1, and 1 squared is 1. And we take the length of the other leg and square it, so the length is 1 squared, which is 1. It would equal this length squared, which would be 2 squared. Or I'm sorry, you would get an area of 2. Okay? Which works for all of them. If you take 3 and square it, and 4 and square it, you would get 5 squared for your area here. So the Pythagorean theorem states this. It describes the relationship between the length of the legs and the hypotenuse. So if you take the length of each leg and square it, it will be equal to the hypotenuse squared. So now that we know that, at the bottom, it wants us to find the length of the hypotenuse. So use what you know about square roots to determine the length. So if we know the area of a triangle, then that means we can find the length. So if we know that the first area, here's my right triangle that I was given, and this length was 1, and this length was 1, this area was 1, and this area was 1, and this area was 2. Those are the units, square, unit, square, and unit, square. Then to find this length right here, we would have to take what we call the square root. So the square root of 2 would give us our length of the third side of the triangle. So let's go ahead and do that. So if we take our calculator, and we put in the square root of 2 and hit enter, we would get, I know it doesn't show up very well, 1.41. We'll go ahead and round just to 1.4. So the length of the hypotenuse for A would be 1.4. Now let's look at B. At B, I want to know this length. It's across from the 90-degree angle. My area was 5, so to find the length, I have to take the square root of 5. And that would give me 2.36. So we'll just say 2. Let's round to 24. Okay, C, the square root of our hypotenuse is across from the 90-degree angle. So we got to find the square root of, sorry guys, this is our hypotenuse across from the 90-degree angle, so we have to find the square root of our area, which is 13. The square root of 13 would give me 3.605, so we'll make that 3.61. Okay, so now that you know what I'm doing, I need you to find the length of the hypotenuse for D, E, F, and G. So pause the video and find it. Okay, so you should have found the area of D, and what did you get? Okay, so you should have got 10 squared. I'm sorry, the square root of 10, which would give me 3.16. Okay, now for E, what did you get for the length of the hypotenuse for E? Okay, well, here's my hypotenuse, and the area was 25, so you should have taken the square root of 25, and you would have got what? 5. Okay, F, what did you get for the length of the hypotenuse for F? So you should have got 2.83, and then for G, you should have got the square root of 18, and you should have got 4.25. Okay, so using this investigation, we just figured out that the area of the right triangle squares is equal to the area of the triangle's hypotenuse squared. Okay, so now we're going to put that aside, and we're going to look at investigating Pythagoras. So for investigating Pythagoras, what you're going to do is you're going to look at the different types of triangles. The first triangle is a right triangle. So this should be a right triangle here. So in the first one, for number 1, we're going to put right triangle. Now it asks what is the length of A, so we're going to put 3. What is the length of B? We're going to put 4. And what is the length for for C, the hypotenuse, we're going to put 5. Now it's telling us to take A and square it. So my A is 3, and we're going to square it. And that would be 3 times 3, which is 9. Then we're going to take 4 and square it. And that's going to give me 16, because 4 times 4 is 16. And then we're going to take C, which is 5, and square it. And 5 times 5 is 25. And then it wants to know, does A squared plus B squared equal C squared? Well, let's see. A squared is 9 plus B squared is 16. Does that equal 25? Check, that is correct. Okay. So for the next one, on 2, you're going to have what's called a obtuse triangle, because there is an obtuse angle. It's not a right triangle, so we're going to call that an obtuse. I'm going to do one more with you, and then you're going to do the rest by yourself. So A, it says 3, right here. B, it says 4. And C, it says 6.4. Then it wants us to square it. So we're going to do 3 squared, which is still 9. 4 squared, which is 16. And then we have 6.4 squared, which is, I got to look at my calculator. Let's see. So we have 6.4 squared, and I get 40.96. Okay. Then it says to add a squared plus b squared, does it equal c squared? So we're going to have 9 plus 16, does that equal 40.96? Well, it can't because we found out that 9 plus 16 is 25, so this does not work. Okay? All right, so pause the video and do number 3, 4, 5, and 6. So you should have done 3, 4, 5, and 6, and you should have discovered whether a squared plus b squared equals c squared. So for 3, you should have had it filled in, and you should have done 12 squared plus 5 squared equals 15.2 squared. So did you get, does it equal each other, yes or no? So when I got 12 squared plus 5 squared, I got 169, and if I did 15.2 squared, I got 231. So this does not equal each other. Okay, now go ahead and put your answer for number 4 in, just like I did with the squares, and tell me whether or not it equals. Okay, you should have put 12 squared plus 5 squared equals 13 squared. So did you get it? So it should have been 12 squared plus 5 squared, and you should have got 169. Does that equal 13 squared? And that is a true statement, so you should have checked that one. Okay, number 5, you should have everything filled out. Oh, and so on number 4, was it a right triangle? Yes, it was. Especially if a squared plus b squared equals c squared works, then it is a right triangle. And number 3 was an obtuse again. Okay, number 5. You should have had what? Go ahead and write your formula in and tell me whether it's true or false. So you should have gotten acute, is what I thought it was. But if it works, then we know it's a right triangle. So let's put in our work. So we would have put in 4.5 squared plus 6 squared. Does that equal 7.5 squared? Did you hopefully put in true or false when I asked you? So I got 56.25 for the first part, and 75 squared would give me 56.25. So this is a true statement. So this would have to be a right triangle. It does look like a right triangle. If you look right here, that would be your right triangle. All right, last one. And we're done with our investigating. So we had 4.5 squared plus 6 squared equals 6.1 squared. Well, you should have put in that you did what? Did it equal or not? No, it wouldn't have equaled because this is the same one except they just changed it. So the question asks, what do you notice about the length of the sides C in each triangle compared to the lengths in the sides A and B? So what do you notice about the length of the sides C, so here's C, in each triangle compared to the lengths of the side A and B? So go ahead and write your response. So you should have said that you noticed that the length of C is always the longest length of the triangle. And what did you notice about the sum in a right triangle that when you should have, so go ahead and write your answer to that. What do you notice about the sum of a squared plus b squared in the right triangle listed in your table? So what you should have noticed that if it is a right triangle, that the a squared plus b squared equals c squared would have equaled each other. And that was obvious by these right here. Now, if it didn't equal each other, then they're definitely not right triangles. All right, awesome. So you guys were able to investigate the Pythagorean theorem. You should have a better understanding of what it looks like. Once you finish, raise your hand, and the teacher will come around and hand you out 3 problems that you'll finish on your own. Make sure you keep this classwork because your teachers will be checking and making sure you have it, and then they'll be taking up your 3 problems that you'll be solving. All right, thanks for listening. Hope you liked it.